Namaskar. My name is Mukesh Ramesh Chandra Srivastava, or Mukesh Srivastava. And let me first share the screen with you. I will take you through IBDP math analysis and approaches, HL topic, Euler's method for first order differential equations. Let me first share my screen and then I will begin my presentation. Yeah. Yes. Okay. So my topic is Euler's method for solving first order differential equations. This is a topic from IBDP curriculum, IBDP Math AAHL, or Analysis and Approaches HL. Topic number is 5.18. Okay, indexed 5.18. Subject guide of IBDP Mathematics AAHL. The formula given in the booklet is this, which is shown on the screen. Yes, yeah. This is the formula on the screen. Now we start this topic. Let's take a question. Now, why do we need this topic first? Usually you are aware of differential equations, and you're also aware of integration, and you are aware that integration is commonly used to solve differential equations. But sometimes, the function you've got is rather complex, not easily integrable. In such cases, we use Euler's method to get an approximate solution. Correct? So Euler's method. Let's take 1 second. Let's take yeah. Now you consider this differential equation, dy by dx equal to 4 minus y over 10. Now this is a fairly simple equation, but it's just I'm using it to explain the concept to you. This is a question from IBDP Math October 2023 examination. I will repeat IBDP Mathematics October 2023 examination, paper 2. This is paper 2. Okay, not paper 1. Paper 1, they don't let you use the GDC, graphing display calculator. In paper 2, you are allowed to use graphing display calculator, and I have used Casio FX CG50 graphing display calculator. So here we begin. Solve the differential equation dy by dx equal to 4 minus y over 10. Now you are given that when x is 0, y is 2. So these are the initial values. My initial value of x is 0, or x naught is 0. And the initial value of y when x is 0 is y naught equal to 2. We are told to use a step size of 0.1 to find an approximate value of y when x is 0.5. I will repeat. When x is 0, y is 2. When x is 0.5, I don't know. So we have to find. And we will find using Euler's method, using a step size of 0.1. So let me just sum up the initial discussion. My initial value is x equal to x naught, which is 0. And initial value of y. Initial value of y is y naught, which is equal to 2. So x naught equal to 0 is the initial value of x. Y equal to y naught equal to 2 is the initial value of y. The final value of x is 5. Final value of y, we don't know. We have to find. And the step size is 0.1. Okay? The step size is 0.1. Now step sizes, 1 second, yeah. Step sizes given by the final value of x minus initial value of x, okay, divided by step size. That is the number of steps. So how many steps are required? Number of steps is final value of x, which is 0.5, minus initial value of x, which is 0, divided by step size. 0.1 is the step size given to us. So we will take 5 steps. X naught equal to 0 is 1. X1 equal to 0.1. x2 equal to 0.2, x2 equal to 0.3, and x4 equal to 0.4, x5 equal to 0.5. So there are 5 steps, correct? 5 steps, and so we go to the main menu, which is of Casio main menu, and then we press 8. 8. When we press 8, this recursion tab opens up. Recursion tab. Okay, recursion. Then we press execute, EXE. We go to the next screen. On the next screen, we will type F2. F2 is this, AN plus 1 equal to AAN plus BN plus C. So that is my F2. Now, remember, xn plus 1 is an plus 1. We are not using x, y, and whatever. For x, we are using A. For y, we are using B. And we are not using C now. So xn plus 1 is an plus 1. Right? Yn plus 1 is bn plus 1. Correct? So, I'm sorry. So n plus 1 is en plus 1. Yn plus 1 is bn plus 1, and cn plus 1 is not relevant. Okay, now let us see. My step size is 0.1, correct? In this problem, it is x1 minus x0 is the step size. So x1 is x0 plus h. Step size h is 0.1. So x1 is x0 plus 0.1. x2 is x1 plus h, right? So x2 is x1 plus h is 0.1, so x1 plus 0.1. x3 is x2 plus 0.1. xn plus 1 is xn plus 0.1. Again, an plus 1 is an plus 0.1. Because we are not using x and y, we are using a and b. Correct? Okay. Now, now imagine a straight line, okay, and the gradient of this straight line is y1 minus y0 over x1 minus x0, which you know from your study of differential calculus that gradient is given by dy by dx. So dy by dx is y1 minus y0 over x1 minus x0, which is equal to dy by dx. So y minus y0 over h, x1 minus x0 is h, is equal to dy by dx. So y1 is y0 plus h times dy by dx. This means, now dy by dx in this question, in our question dy by dx is 4 minus y by 10 is given to us. Dy by dx is 4 minus y over 10. So y1 is y0 plus h times dy by dx, we saw here. y1 is y0 plus h times dy by dx. So y0 plus h times dy by dx. And dy by dx is 4 minus y over 10. So now we know x0, y0. So we will use those values. So y1 is y0 plus 0.1 into 4 minus y0 over 10. Correct? Now what is y0? I said we are not using x and y, we are using a and b. So a stands for x, b stands for y. So y0 is b0. And y1 is b1. y2 is b2. y3 is b3. yn plus 1 is bn plus 1. So yn plus 1 is bn plus 1, which is equal to bn plus 0.1 into 4 minus bn over 10. Is that clear? Should I repeat it? My y1 is y0 plus 0.1 into 4 minus 1 over 10. 4 minus y0 over 10. So similarly, therefore, bn plus 1 or yn plus 1 will be bn, 1 less. bn plus 0.1 into 4 minus bn over 10. Now I will go to, so I put an plus 1, I put bn plus 1. Now I will press set. Set is will be F5 on your GDC. Just a minute. Yeah, it is F5 on your GDC. When I press F5, I go to set and I get this screen. My start, where am I starting? My initial value is x naught, x0. So I'm starting at 0. My final value is x5. So I end at 5. Right? X naught, which is 0. So starting value is 0. Ending value is 5. Okay, because I am ending at x5. Now initial value is x naught, which is 0. It is given to us in the question. Final value is initial value of y is b naught, which is y naught, which is 2. So x naught, y naught are given to us. Correct? Would you like me to go back to the screen? Let's see. My initial value is x naught equal to 0. X naught is a naught, so a naught equal to 0. Initial value of y is y naught equal to b naught is 2. And dy by dx is 4 minus y over 10. Right? So I've got this. I've entered the values. Now I'll press table. Table is F6. So when I press table, okay, when I press table, I get these values. So I know that when x, A stands for x, right? So when x is equal to 0.5, my y is 2.08900199. So rounded to 4 significant figures, it is 2.098. That's my final answer. When I write this answer, I get 3 marks. Is it clear? Yeah? When I write this answer, give your answer correct to 4 significant figures. 3 marks. So I got the value of y when x was 0.5. The value of y when x is 0.5 is 2.098. Rounded to 4 significant figures. Okay. Now let's take one example. Yeah. One more example. This example is given the differential equation y dy by dx equal to 1 minus y minus xy over 4 minus x squared. Now, what are my initial values? Let's write the initial values. My initial value y naught is 1, which means value of y when x is 0 is 1, which means my initial value of x is x equal to x naught equal to 1. And this will be a naught, okay, in my calculator. Now y naught, which means when x is 0, okay, when x equal to x0, when x is 0, y is 1. So my initial value of y equal to y naught is 1. I'm so sorry, I made an error here. Initial value of x naught is 0. And when x is 0, y is 1. Okay, that will be 1. This is my p naught. Is that correct? Initial value is x naught, which is 0. Because this means y when x equal to 0 is equal to 1. So my initial value of x is 0, x naught is 0. My initial value of y is 1, so b naught is 1. Correct? Now use Euler's method with h equal to 0.25. So my step size is 0.25. Correct? My step size is 0.25. So how many steps will be there? From x equal to x naught, let me draw a number line here. Okay. Initial, okay, and also my y-axis will be here. Okay. So now, when x is x naught is 0. So this is my x naught. I will take a step of 0.25 to x naught plus 0.25, which is x1. 0.25. So x1 is x naught plus 0.25. 0, 0 plus 0.25, which is 0.25. So my x naught is this. Okay, is 0.25. x1 is 0.25. x2 will be x1 plus 0.25. So it will be 0.5. x2 is 0.5. x2. x3 will be 0.75. x0, x1, x2, x3. x3 will be 0.75. And x4 will be 0.75 plus 1 is equal to 1. Correct? x0 equal to 0. From 0, I took a jump of 0.25. So this became, x1 became 0.25. Again, I took a jump of 0.25. x2 became 0.5. Again, a jump of 0.25. x3 is 0.75. Again, a jump of 0.25. So x4 became 1. Right? Okay. Now, this is, so how many intervals I've got? I've got interval 1, interval 2, interval 3. This from 0 to here, this is one interval. Second, third, fourth, four intervals there. Okay. First interval, second interval, third interval, and fourth interval. After the fourth interval, I reach 0.5. 1.0, sorry. Correct? Now I know that when x is x0, y0 is 1. This I know. This I know. When x is x0, y0 is 1. This is given to me. I don't know what is x, y when x is x1. I don't know what is y when x is x2. I don't know what is y when x is x3. I don't know what is y when x is x4. For this, we will need Euler's method. Okay. So let me say I draw a tangent here. This is my tangent. My tangent is this. So gradient of tangent is dy by dx equal to 1 minus xy over 4 minus x squared. Okay. So gradient of this tangent, okay, this at x0, y0 will be 1. Gradient of this tangent, I will write here, is dy by dx is the gradient of the tangent. So my value of y, the value of y when x is y1, I don't know. I can find the value of y. Value of y is y1 minus y0 over x1 minus x0. And x1 minus x0 is how much? It is 0.25. That's equal to dy by dx. And how much is dy by dx? dy by dx is 1 minus xy over 4 minus x squared. Now, do I know xy? Of course. x0. x0 is 0. x0, y0. Over 4 minus x squared. 4 minus x0 squared. Okay? This I know. And this is h. This is 0.25 h. So therefore, since I know this, I can say that, let me erase this. I can say that y1, when I simplify this, I can get y1 equal to y0 plus h times dy by dx, h times 1 minus x0 y0. So x0 is 0 and y0 is also is 1 over 4 minus x0 square, 4 minus 0 square. So y1 will be equal to y0. y0 plus h. h is 0.25 multiplied by 1. Right? This is 0. 1 minus 0. So my y1 is 1 plus 0.25, which is 1.25. I've obtained this point. So my y1 is This point is x is 0.25, y is 1.25. Now I want to find y2. I'm going step by step. This was my first step. My second step, I'll go to x2. Now x2, let me make some space here. Okay, leave it. I'm not able to make space. Leave it. Okay. Now here I will draw. I want to find the value of y when x is x2. So now I know dy by dx. When x is x1, y is y1. I know. So I'll draw at this point. I will draw tangent because I know dy by dx now. At this point, dy by dx is for this line is 1 minus x. I'm taking this point now. x1 y1 over 4 minus x1 squared. I know this, so I can find. So using this, I can find my value of y2. Y2 will be y1, which is 1.25, plus 0.25 into 1 minus x1 y1. Now it will not be x0 y0. It will be, I've drawn tangent at this point. So x1 y1, 0.25 into 1.25 over 4 minus 0.25 square. Yeah, x1. I can find y1, yeah, y2. Similarly, I will find y3. Next, I will draw a tangent at this point to find y3. Then I will draw tangent at this point. I'll draw tangent here, get y3. Then I will draw tangent at this point to get y4. Correct? To get y4. So this is how I obtain values of y1, y2, y3. I don't go beyond y4. Once I've got y1, y2, y3, y4, I stop because I want to find the value of y when x is x4, which is 1. Now this we will do on the GDC. Okay? On the GDC. So on the GDC, I have chosen F2. I have chosen F2, correct? Yes, I have chosen. F2 is this. I have chosen F2. Now, now what I will do is, it's a recursion equation. Now an plus 1, in place of x, we've got a. So an plus 1 is xn plus h. H is 0.25. And bn plus 1 is bn, or xn is an. This is an. Bn plus 1 is, no, b is y, right? So yn plus 1 is yn plus 0.25 into 1 minus 0.2, I beg your pardon, 1 minus xn yn. Correct? I'm using the previous values over 4 minus xn squared. Is this correct? I'm using previous values. See, when I wanted to calculate y by 1, I used x0 y0. You know, I used x0 y0 to calculate y1. I used x0 y0 to calculate y2. I used x2 y1, x1 y1. I beg your pardon. To calculate y1, I used x0 y0. To calculate y2, I used x1 y1. To calculate y3, I used x2 y2. So to calculate, I'm using the previous values of x and y. So to calculate yn plus 1, I will use x and yn, which I can write in terms of b. In terms of b, I will say this is bn plus 1 equals bn plus 0.25 multiplied by 1 minus an bn over 4 minus an square. Okay, I enter all these values in the table. So my GDC screen will look like this. This is my GDC screen. It's gone. Okay, that screen I have not shown. And I set my initial values. Initial values are, now I am starting with x naught. Okay, I am starting with x naught. I am going till x4. So my start value will be 0. End value will be 4. Now initial value of x, or which is x naught, is 0. It will be 0. Initial value of y, which is y naught, is 1. So it will be 1. This will be equal to 1. Yeah? So my x naught will be 0. Start is 0, end is 0. Start 0, correct. Start 0, correct. End 4. A naught start 0, correct. B naught is 1. Okay. So now when I do this, I have put the values, put the formulae, I have set the values. Now I will press F6 and go to table. Now when I go to table, my screen is like this. I'm so sorry. My screen will be like this. Screen will be like this. This is my screen. So my value of y when x is 1 is 1.839139. Okay? My value is 1.839139. This is my value of y when x is 4. Value of y when for x equal to 4. X equal to 1, I'm sorry. X equal to 1. So my x is 1, y is 1.839, and this is my calculator display. Now, usually in IBDP, we give final answer to 3 significant figures. So I will give 1, 2, 3. I'll stop here. It's 1.84. However, in the previous question, they had asked us to give the answer to 4 significant figures. So if I have to give the answer to 4 significant figures, I will stop here. 1, 2, 3. I'll stop here. So 1.839. This is 3 significant figures. It will be 1.839 to 4 significant figures. Correct? So with this, I will end my presentation on Euler's method. Yeah, in Euler's method, we found when should Euler's method be used. First, second, what is the step size? Step size is the final value minus the initial value over the number of steps. Now, in this case, step size was given; it was 0.25. Correct. So the number of steps will be final value minus initial value, number of steps is final value, which is 1 of x, initial value of x is 0 over step size is 0.25, so which is 4. So you will either be given the number of steps or the step size. Yeah, step size is h, small h. So if you are given h, we can find number of steps. Conversely, if you are given number of steps, we can find h. Right? So with this, I will end my presentation. But I will not before giving you some homework. So the homework is this. Apply Euler's method with step size h equal to 0.1. You're given the step size. Okay. So number of steps will be how much? You want to find the value of y when x is 0.5. The initial value of x is 0. You have to find the number of steps. It should be, you can find it, yeah? So these are the two homework. Exit tickets. Solve this and please email it to me. I will check and give you feedback. So thank you very much. Okay. Thank you very much. And let me end this discussion now. So thank you.